everybody. This is Mrs. Snook with a section of 4.3 Day 2 notes. 4.3 is about right triangle trigonometry. Last time in class, we found sine, cosine, and tangent using SOHCAHTOA. Where SOH was sine opposite over hypotenuse, CAH was cosine is adjacent over hypotenuse, and TOA is tangent opposite over adjacent. Today we're going to finish off section 4.3, and our objective is to use fundamental trigonometric identities and to use trigonometric functions to model and solve real-life problems. So first up is the trig identities. We have three different kinds. We have reciprocal identities, quotient identities, and Pythagorean identities. And it's going to be very useful to you if you memorize these identities. So first up is the reciprocal identities. So reciprocal, as you know, means to flip the fraction over. So if I gave you 4/3, the reciprocal, just flip that over and you get 3/4. So the sine of theta is 1 over the cosecant of theta. And that also implies that the cosecant of theta is 1 over sine of theta. So if I gave you, let's say sine of theta is the 3/4, and I said to you, what's the cosecant of theta? You would just flip that 3/4 over and give me 4/3. We also have a reciprocal function with cosine of theta, and that is cosine of theta is 1 over secant of theta. And then, of course, secant of theta is 1 over cosine of theta. So it's just like what we just did with the sine of theta. All you got to do is flip these over to go back and forth between them. And last one is tangent of theta is 1 over cotangent of theta. And then cotangent of theta is 1 over tangent of theta. So those are the three reciprocal identities that we're going to use. Our second kind of identity is the quotient identities. There's really only one, but there's a second one that you can get very easily. Quotient means dividing. So tangent is the quotient of sine and cosine. So sine over cosine is your tangent. And because we know that cotangent is 1 over the tangent, you can then say that the cotangent of theta is cosine of theta over sine of theta. And this is the second one, but it just comes straight out of what we already know. Our last one is the Pythagorean identities, and there's 3 of these. These actually come from Pythagorean theorem. So if you remember, c squared equals a squared plus b squared. From this, you can actually derive the first one, sine squared theta plus cosine squared theta equals 1. And this one is probably the one that I use the most. The second one is 1 plus tangent squared theta equals secant squared theta. And the last one is 1 plus cosine squared theta equals cosecant squared theta. And in the example problem that we're going to do, we're going to use some of these identities to solve the problem. So here goes. Let theta be an acute angle such that cosine theta equals 0.8, and we're going to use that information to find the sine and the tangent. Do not find the angle, because we're going to do this in a new way. Your old way would have been to figure out what theta was and then punch up sine and tangent. But we're using a new way today. So the first thing I'm going to do is I'm going to grab a Pythagorean identity, and my favorite one is the sine squared theta plus cosine squared theta equals 1. And that's going to let me put in my cosine theta, and then I can calculate the sine. So let's go ahead, plug in what we know. All right. So I have all numbers except for sine squared theta, so I can very easily solve for that. So sine squared theta plus 0.64 equals 1. Subtract the 0.64 from both sides. And then take square root of both sides. So that gives me the sine of theta. Now you may recall that the rule of thumb when solving by square roots is if you have to write in the square root, then you take plus or minus. So by that rule, I have to take plus or minus 0.6. But at the start of the problem, I underlined that this was an acute angle. Acute means it's less than 90 degrees. So if I was to draw a picture in our XY plane, theta is somewhere here. And the sine and the cosine are both positive because we're in the first quadrant. So therefore, I'm not going to take both plus and minus. I'm just going to take the positive. So my sine of theta is 0.6. All right, I've got sine of theta. That's one of the two values I need to find. The other one is the tangent of theta. Now I have some choices. If I wanted to, I could go back and say, oh look, here's tangent squared theta right in here. So I could grab 1 plus tangent squared theta equals secant squared theta, and then I would have to remind myself that secant is 1 over cosine. So this equation I can use to relate tangent and cosine, but I have another choice that I think is easier. Right over here in our quotient identities, I've got tangent of theta equals sine over cosine, and I know both the sine and the cosine. So I'm going to go ahead and use that. So tangent theta equals sine of theta over the cosine of theta. Sine is 0.6. Cosine was given to us as 0.8. So now tangent of theta is 0.75. And that finishes that problem, and we did not even have to know what theta is. All right, the next example we're going to do is solving a right triangle using our trigonometry. This is the real world example. We have a surveyor standing 50 feet from the base of a large tree. Now, if you don't know, a surveyor is the people that you see on the side of the roads, and they'll have a tripod and this big funky camera looking thing. And usually what they're doing is measuring the length of the road, finding exact locations of buildings and, I don't know, trees, plants, you know, anything that someone might want to know. Maybe they're looking to find the exact location of a property line. So that's what a surveyor is. And this surveyor is standing 50 feet from the base of a large tree, and they measure the angle of elevation to the top of the tree as 71.5 degrees. How tall is the tree? So first thing I want to do is draw a picture. So I'm going to draw my tree. There's my tree. I'm going to have the ground. Here's my surveyor. And then in red, I'm going to put in the right triangle. We're looking for the top of the tree, which is there. Here's this. So there's our right triangle. I'm going to label what I know. I know that's 50, and I know the angle of elevation is 71.5 degrees. So now I need to figure out how tall the tree is. So I'm just going to go ahead, I'm just going to call that y for how tall the tree. It's going to be y. And I need to choose a trig function. So if you remember from last time, here's our angle. So we're going to label our sides. This one's opposite, this one's adjacent, and this one is the hypotenuse. I know the adjacent, I want the opposite. So if I go to SOHCAHTOA, the one that has both opposite and adjacent is TOA. So I'm going to choose tangent. So tangent of 71.5 equals opposite, which is y, that's what I'm looking for, over adjacent, which I know is 50. And then to solve for y, just multiply both sides by 50. Those 50s cancel. And you're going to get y equals 50 times the tangent of 71.5. Make sure you're in degree mode. And you'll get 2.98. And then y equals, I'm just going to multiply on my calculator. And I got 149.4, let me get this, 2.98 times 50. I got 149.4, I think. And that is feet. So if I look at this picture, what this means is the tree is about 3 times as tall as the distance away from the surveyor. So thanks everyone for watching this video. Have yourself a great day, and I'll see you next time.